In our first part of the video, we learned about calculating the IRR, internal rate of return, and also we tried to verify it. And when we verified it, we found that the value of NPV was not precisely equal to 0 by using the interpolated IRR. So there is some problem with the interpolated IRR, which might be small, but it is there. So let's try to figure it out. What we have done is we have found a manual interpolation or interpolated IRR. We have done manual interpolation of it. So when we do the manual interpolation by using the formula and the calculation we did, it can cause some overestimation in IRR. Here the interpolated IRR is 26.7705%. But if we use computer, it can give us precise answer of IRR, which is actually the true IRR or the actual IRR. So that would be this. So you can see that there is a difference. Overestimation definitely can be calculated, that the interpolated IRR and the true or actual or computer generated IRR is this. So this is the level of overestimation in our answer, due to which the NPV was not equal to 0 when we tried to verify it. Let me take you to that just for the sake of reference. Here you can see the NPV was not precisely equal to 0, was minus 0.298, so it's not precisely equal to 0. For this thing, we want to clarify that what is happening here. There is this level of overestimation. Now graphically speaking, we can understand this thing. On x-axis we can make discount rate, and on y-axis we can make NPV, because on discount rate depends the NPV. And this is a curve. This is a negatively sloped curve. It is actually showing the true IRR at this point, and because at this point you can see that the level of NPV is 0 because we are on x-axis, and the value of y-axis at x-axis is 0. And when NPV is equal to 0, we know that we have an IRR. So here the NPV is equal to 0. Again, at this point NPV is also equal to 0, but this time the reason is not the curve, rather the straight line. So the straight line actually is representing the interpolated IRR, one that we calculated. However, this curve was showing the true IRR relationship, which is also negative. Both of these curves, as you can see, they are negatively sloped because of the negative relationship of NPV and discount rate. However, one of them is a straight line and the other one is a curve. Curve is the actual one. However, this straight line is the interpolation, and as you can guess that interpolation is a kind of average. This is why we have a straight line, because in average we kind of take 2 points. One of them in this case is the lower discount rate and the other is the higher discount rate, at which we have calculated or we have found lower NPV at lower discount rate, and this is the NPV at higher discount rate. And definitely this was the negative value and this was the positive value. You can refer back to that video and see what were the exact values. Roughly speaking, it was about 6 and this was about minus 1 point some value. So, and we should also try to highlight this. It was 23%, this lower discount rate, and this was 28%. So these are the 4 values that we used in that calculation, and these were the values that we used to find out the interpolated IRR. So after all the labeling, we can see that there are 2 IRRs. One of them is this one, which is the true IRR, and this is the other value, the interpolated IRR. So we should try to label this as well in order to avoid any trouble. This is the interpolated IRR and this is the actual IRR. So actual IRR is 26.57, whereas the interpolated IRR is 26.77%. This area is actually the overestimation, which is equal to minus 1.1996. This is the difference between the two. Since we are not following the actual curve, we are following the straight line, we have this overestimation, and this overestimation needs to be minimized. We can talk about how we can minimize it. Let's we will also numerically verify it, but just for the sake of understanding of how we can minimize it, if this is a curve and if this is a curve, there is a difference between the overestimation. This will be a greater area of overestimation, and if this is the curve, only this will be the overestimation, this much. So you can see that if the difference between the higher and the lower values is small, the overestimation will reduce. In case of the outside curve, the higher and the lower values are at quite a bit of distance, whereas in case of this smaller inside curve, the lower and higher values are closer to each other. So the difference between I lower and I higher should be kept to minimum in order to avoid this overestimation, as you just saw in the diagram. The closer it is to the straight line, the better. For example, if I have this interpolation and if the actual IRR is this, so you can see only this much of the overestimation is there. But if I have such a set of such a curve, then definitely there will be this much of the overestimation. So this straight line should come here in order to reduce it, and when it comes here, it means that the lower and the higher values are getting close to each other. So this is the gist of it. Let's numerically verify it. We have numerically verified it by using the interpolated IRR and the computer generated or actual IRR. This is the verification that we have done in the last part of this topic, in which we use these columns, that is net benefit and then discounting factor at IRR and the discounted net benefits. So all three of these columns are generated here as they were done before. However, we have used the interpolated IRR in this case and the original or computer generated IRR in this case. The remaining things are the same as they were before. This is the value of the discounting factor for the first year, for the second, for the third, and so on. Here again, for the first year, the discounting factor, and then for second year, third year, fourth year, and this is for the actual IRR, the computer generated IRR. This is the product of the two, that is the net benefits of the first year and the discounting factor. The answer is this. So in this way we can calculate all these values. Here again the product of the two will take place and it will give us this value. So we have this series of value here again. This is something we did before in the last part of the video, in which we found that it was not precisely equal to 0, the NPV at interpolated IRR. So it was not precisely equal to 0. Whereas by using this computer generated IRR, we have found that the NPV is equal to 0 precisely. And yes, this is something we wanted. So it verifies that thing, that the NPV will be equal to 0 if we are able to get a precise IRR. And IRR cannot be much precise as long as the difference between the I lower and the I higher is substantial. So we verify this thing. The interpretation of all of it is that the overestimation of IRR was this much, that is 0.1996, and it pushed the NPV below the zero level, that is it was negative value, and it was pushed uh, down from 0 by 0.2908. So it means that IRR was not precise, and the overestimation had its effect. So what is that we can do? We can minimize the gap of the lower discount rate and the higher discount rate in order to get a more precise estimate of the IRR. 5 is recommended by the that is basically a convention followed in most of the countries. However, it can be reduced. The lesser it is, the more precise the IRR estimate will be. So this is how we can understand one of the limitations of IRR, and the solution of that is also recommended. We have numerically verified and compared the two situations, and the solution is that we should minimize the gap between the lower discount rate and the higher discount rate. In this way, we have completed the IRR, its understanding, its concept, its calculation, its verification, and finally in this part of the video, the limitation and its possible remedy. Thank you.